Hi everyone, and welcome to CE 5203/6203 Transportation Planning. Let's get started. Westmoreland Street Bridge. If there are two major points that I could make for you about this course, and I realize the camera is kind of bouncing around a bit. There are two major points that I can make for you. It's this: that transportation planning is about understanding the present and planning for the future. So think about what those things mean. Understanding the present and planning for the future. We'll also get into the past as well, because that helps us understand the present. But as we get onto the Westmoreland Street Bridge, I think this bridge provides a really good case study, because this is a project, again, that has come out of a transportation plan. It has come out of a transportation study that said we need to address this particular transportation issue in our city and think about all the questions that we would have to ask about the construction of a bridge like this. How many lanes are you going to need? What's its function going to be? How wide is it going to be? This is the busiest highway in the city. Can you guess how many vehicles a day are on this bridge? 5,000, not 10,000. If you said those numbers, it's much higher. If you said 50,000, then you are correct. So as we're looping around this bridge, I want you just to think about the difference between what is transportation planning, what is geometric design, and what is traffic engineering. We'll get into those in a bit more detail soon. You can even notice the sidewalks. So if transportation planning is about understanding the present, then we need to know how many vehicles a day are using this bridge. But about understanding the future means predicting the planning for the future. Now there's a difference between predicting and planning for the future. And we cannot predict the future. But certainly what we can do is plan. And that means getting an understanding of, well, what are the needs going to be 20 or 30 years down the road for a bridge like this? Are we going to still be driving? Or are we going to be using the Hyperloop? Are we going to be on drones? Are we going to be doing a lot of work? Is the fact that we're working remotely a lot now going to influence how we do transportation in the future? So those are all the things that I want you to think about when it comes to this introduction to transportation planning. It's understanding the present. What do we need to do to understand how things are today? Is it about data? Is it about collecting information? Is it about practices? What are those things? Then how do we look for planning to the future? And these are the kind of tools, we're going to talk about the kind of tools that you're going to need to be able to do those kind of planning for the future. So while we're not really great at predicting the future, there's a lot of things we could do to plan for the future. Now, the place where I'm standing right now used to be Canadian Pacific Railway. This is actually right out front of the main gates of the UNB campus. So at one time, this was the rail line that you would take from Fredericton to go to St. John and to connect into Montreal. Going this way takes you over to the Bill Thorpe Walking Bridge. So can you imagine, at the time when this was built, it wasn't conceived that there would be a future where this would be actually paved over and turned into an all-purpose walking and cycling trail. But that's the interesting thing, again, with the difference between trying to predict the future and plan for the future. In the sense that we couldn't have predicted 100 years ago, when trains were everywhere, that we would be paving those trails over. Yet, when the opportunity arose, when the rail lines were being abandoned, as was the case here in the mid-90s, there was an opportunity to turn these rails into something that would serve an even bigger need for passenger movements here in the city. I don't think anyone can imagine the city without the trails that it has now. But when they were first pitching the idea, it did not have a whole lot of support. It took a long time. But now we see active transportation is everywhere. And in fact, what's really interesting about this particular spot is years ago, when the rail lines were taken out and the trails hadn't been put in yet, this is actually where I parked to go to class. It was just outside of the UNB campus, and we're parking at the bottom of the hill here and running up the hill to my physics class. So anyway, can't predict the future, but when faced with a situation, transportation planning can help us plan for the future. So how does our profession define transportation planning? And the strict definition is that transportation planning is the functional area within transportation engineering that deals with the relationship between land use to travel patterns and travel demands. So let's first focus on the land use component. And I'm here at the corner of Smythe Street and Wagoner's Lane because I think this provides a really good example of the different types of land uses and the impact on transportation. So if you look behind me here, you're going to see the Superstore. This is a grocery store. And you can see it's got a really big parking lot, lots of traffic going in and out of this area. On the other side to me here, we've got apartment buildings. And this is a very different land use, right? So think about, we have one place where people live, one place where people shop, and the difference in the type of travel demands that people are going to be making to go to one versus the other. Whether it's the number of times a day someone leaves, the mode of transportation that they use to get there, the idea that there's a connection between the land use, like the Superstore, like apartment buildings, and how people use transportation. Also in terms of what transportation planning is, so we've defined it about functional planning and transportation and land use. It's also about planning and evaluation and programming of transportation facilities, including roadways, transit, terminals, parking and pedestrian facilities, bikeways and goods movement. Which is why I think this is an interesting location and why I've chosen to stand in front of a bus stop. We are in an industrial area, so not only do we have a land use question, so there are industrial buildings around us. Each of them would have, freight movements or people coming and going. But in addition, right? Here's that interface. We've got a transportation planning decision involving transit. We need to have programming for that in response to some kind of land use and the travel demands for that. I'm here in the head hall parking lot, and as you can see, there's not very many cars here. And that's unusual compared to what we're used to seeing here, right? We know that what I call the Windsor Street Shuffle is when people come in here looking for a spot and they back up, turn around, and back onto the road again. The idea here, though, is that we know that during the normal times, the parking lot here around Head Hall is full very quickly. Now, geometric design tells us that this is how we design a parking lot to fit a certain type of constraints. How wide the aisles need to be. Can vehicles make the turns? Traffic engineering would look at the traffic flow. It could tell us the flow coming out of the area of these parking areas and determine how that's going to impact the traffic flow on the major road. But the idea of transportation planning goes to an even more fundamental question. Is parking the right answer? How can we change behavior so that we use parking more efficiently? We can use these technical tools and formulas and models to help us test scenarios before having to actually do it in real life. So we just completed a very epic journey around the city of Fredericton in this first video. And by doing so, we discussed a number of concepts. The first concept about transportation planning. First of all, it's about understanding the present and planning for the future. Understanding the present, meaning collecting the kind of information, doing our background research, understanding how the current situation came to be. Planning for the future means using that information and forecasts and other things that can help us extrapolate or look to how the future might be and plan for what it could be. Like I said, we can't predict the future. But with our tools, we can help plan for a future based on the forecasts that we do. The second main lesson today, second main concept, is about the difference between transportation planning, traffic engineering, and geometric design. All three work together. All three relate to transportation but do slightly different things. So understanding how transportation planning fits, both as an input to geometric design and traffic engineering, and as an output, sort of this cycle where we can take information from each and make it an iterative process. And we also learned about what transportation planning is in terms of the strict definition by the Institute of Transportation Engineers. We have to remember that this is about meeting society's needs for transportation, whether it's moving people or moving goods. The role of transportation planning is to help provide the evidence that we need to help guide us going forward. So, until the next video, let's celebrate a nice warm day with this Starbucks coffee. Refreshing.